Hello class. This will be the first in a series of videos where we'll create a component-based application. A component-based application is one where we separate out different functionality from different pieces of the project. Here's a little bit of what our final project solution will look like. Ours will be a little bit different, but we'll have a drop-down list to choose the type of student to display, and then in a list box, we'll see a list of student IDs that are that type. If we click on a student, we'll see information about the student. So in this project, we're going to create a class structure to help us implement what we have. Let me close this. And open this. Whenever we are trying to separate out the different functionality, the different components in a project, we're going to call those layers. We like to use a 3-layer model at least. Sometimes we even have more layers. But in a 3-layer model, we have one implementation, one layer that takes care of the presentation, the user experience. This could be a website, it could be a Windows-based form, but this is presentation layer logic that's going to usually run on the client machine. So the resources used by the presentation layer can be offloaded to that client machine, and we don't really have to worry about them too much on our end. Now, our business layer is going to be the logic and rules that control our business functions. So this would be our class code, like where our student classes and things like that would reside. Our business layer logic is going to be running on some sort of application server, a backend system. It may be on the same machine as our web server. It might be a completely different machine from our web server, but it's going to control this business logic layer. So it's going to have all the business rules and everything securely maintained in this business layer. Then behind the business layer, we have the data layer. The data could be a database, could be XML files, many different formats. But that data layer is going to be the back end. And so that back end could be running on a database server, some separate machine. This layering allows us to control the resources that are allocated to each different layer effectively. If our database requires more resources, we can put more resources on that database server. If our business layer is slowing down because we have some intensive logic involved in some of our processes, then we can add more resources to that middle server. So this component-based development lets us allocate resources wisely. Besides just hardware, we can allocate our developer resources wisely. We could have front-end developers. We could have business layer logic developers, and then our database people on the back end, so we can split up those job responsibilities effectively. So component-based development is really important in allocating out all our various resources. This 3-layer model can really be summarized as the presentation layer, business logic layer, and the data access layer. And then, of course, there's usually a data source that's driving the whole thing. So our 3-layer app is going to start out with the student class. This is the student class that we created in Chapter 4, and that Rebel class was made available to you where you should have recreated this student object. It goes pretty quick, of course, creating these class objects using Visual Studio. Our student class is not going to carry these score fields because they're unnecessary for our implementation here. As we work on this layered approach, it's going to become more important to us where our executable modules are being stored. Our bin folder is holding all of our executables. We've seen our bin debug folder holds the .exe file that we can just cart off to somebody else and run on another machine. When we create these class libraries that we can import into other projects, we're going to create a DLL library instead. DLL stands for Dynamic Link Library, and it is a a Windows interface that allows us to pull a component into another project without actually bringing the source code in to the other project. So it gives us a way to make that source code safe and secure, keep those business rules and underlying logic hidden, but yet share the capabilities, the external capabilities, the exposed capabilities of that component. So we'll do that with our student project implementation. Cool. So let's get started. I'm going to open Visual Studio. And I'm going to check my TFS connection. It does not look too good, does it? I'm not seeing anything, so I'm going to try to connect. There's some stuff, there's just too much. Now, when I connect to TFS, it's taken me an extremely long time. So while that's running, I think I'm going to create a library, a folder, to hold the DLL, the dynamic link library that we're going to build for this student object. I'm going to create it in my documents folder. And I'll just name it DLL library. This is important because it's going to give me a common place to save these DLLs while TFS continues to roll away. Go connect. And finally then, I will create my new project. Remember, if you get your source code control accidentally under the control of GitHub, you need to delete the .github folder out of your project folder, and you have to view those hidden files to be able to do that. Our earlier video on inheriting the class controls of a form shows you how to do that. Okay, I am ready to create this project. It's only going to contain a class file. I want to generate it as a DLL. So it's going to be a class library type project. I'm going to choose Universal Windows, and I'm going to name this Student Class, because that's really going to be what this is. It's our student class. Now I want to create a directory for this solution within my projects folder, and I am going to add it to source control. So I'll click OK. Now, because we made it a universal Windows application, I have a minimum and target version of Windows 10 to specify for my solution. I'm going to go ahead and choose this oldest version of Windows 10. That's fine for the minimum version. Now again, because it is a universal app, I have the option to set up security settings. We'll leave that for another time. And finally, I'm ready to choose my TFS folder, save location, and I'm going to put it in my CIS151 assignments. This will be my student class. Click OK. Now, when my project gets created, by default, Visual Studio is going to name my class file Class 1. So I'm going to use Solution Explorer to rename that to Student. And yes, I want to rename everything. Now, my student class is not really going to contain a whole lot. First, our private class fields. Last name, first name, let's call it major, and ID. I'm going to check that with our UML diagram. Now, according to our UML diagram, I have these 4 class fields and then 4 associated public properties, and that should be current, major. And of course, I want to match my UML document because other developers are using that same document, and they're going to assume that these match up, right? That our names are the same. Now I'm going to select all these class fields and use the quick actions and refactoring to generate my properties, and I'm going to say to still use the fields. Now I can finish up here and put in another region. My public properties, and I'll put an end region. And of course, the next thing that I need in my class is a constructor. And I could create a constructor, but remember, whenever we're inheriting from another class, oh, we're not inheriting in this one, so we're ready to create our constructor. What am I talking about? Let's do it. Okay, so our first one will be our no-arg constructor. I'll put a comment to that effect. It is a bit of construction, but not exactly what we call it, huh? Now this next one, we're going to say that we're going to expect some names and our ID. So this would be for students that haven't quite decided or we don't know. Now in this case, we want to initialize our class data fields based on these values. Let's make this one use all the fields. All right, so we've taken all these parameter values and used them to initialize the instance of this class. So this constructor requires all the parameters. Next, we'll create a constructor that doesn't know the major. Then let's create one if I can type that only has name. Okay, so we've got our different student constructors here. Let's add a documentation comment. And lastly, our name. Okay, so our class structure is coming along very nicely. That would be the end of our constructors region. And the last thing we need are our class methods. And the only one, again, if we look at our UML, the only method that we need right now is a toString method. And it's going to override the default toString. Press tab on that, and it pops in a little bit of code for us. We want to return the last name plus a comma and a space plus the first name. And that's all that we're going to use in our return statement. It's just the name of that employee right now. So this finishes up our employee class. Let me put a comment here. We'll return string data for our student. Now we should be all set. I need an end region, and then I should be all okay. Now our student class is completely built here. Because we're using a class library, we don't really have a way to test this. We're not going to build a tester and all that kind of stuff. I do want to document the class itself. So our class is used to define a student object, have all our grade information here. I think that we could delete some of these using clauses. Should be the only one that we need. Now we're all clean, ready to go. So I'm going to do a save all. And now I need to generate that DLL. And to do that, I could click start, right? Normally that is how we run our projects. Ugh, sorry about that. Not with this project. We don't really have anything to run. So what we're going to do with this project is build it. I want to make sure I can see my output down here at the bottom. And I'm going to use the build menu, build solution. Now I see from my output, it says that it was up to date. So when I tried to run it, it did build it, but it gave me that annoying error message. Now, if I do make changes and I want to make sure that it's rebuilding, I can choose build rebuild solution, and that will force it to always build a new DLL. So my project is done. I'm going to go locate that DLL. I'm going to right click on my solution and go to Open Folder in File Explorer. Go into my project, my bin folder, my debug folder, and I see that I have a DLL file and a couple of other files. This program debug database is what Visual Studio would use if the debugger was trying to step through the code of this student class DLL. So hopefully we'll have time to try some of these different options of copying these different files. Now, the place I want to copy that DLL to is my DLL library. I created that in my documents folder. I want to copy this thing in there. Oops, it's going to move it, so I better copy. Got them on different hard drives, so it wants to move, and paste. Now I have my DLL in two places, but that's okay because that gives me the option to run my project and revise it without affecting this DLL that I'm using until I'm absolutely ready to affect it and use the new DLL. Okay, so I've got that in my DLL library. I'm done with this project. I should be able to close it. And that is going to be our base. I'm going to double check one thing looking at that project. Saves. One thing that I could get counted off for is this class is not supposed to be something that can be instantiated. It's supposed to be our base class. So I need to put that keyword abstract. My class is abstract. I don't want people to be able to generate an instance of it. So now I need to build it again. It succeeded. And I need to copy that DLL over to my DLL library. The last time I used File Explorer, I could use the folder view in Solution Explorer. The folder view shows us the view of our project in the file system. Again, if I expand my project folder, my bin folder, and my debug folder, I see my student class DLL. I should be able to copy that and paste it into my DLL library. And yes, I want to replace the one that's there. So that works for me. Now I can return my view in Solution Explorer back to my normal solution view, and I'll be back to what I'm used to seeing. I did want to keep this in TFS, so I'll go ahead and check it in. Say it's my initial check-in. Now my source code is safely maintained for me on TFS. I have my DLL file in my DLL library folder, safely saved, so that I could work on this project if I needed to. So we're all set creating our base class. Next video, we'll add classes that extend the student. Thank you.